Hi everyone, today we'll be implementing our RAG pipeline. So I have divided this implementation into two halves. The first half, which is today, will be coding manually or without using some fancy libraries. And tomorrow we'll be looking into some good project using LangChain. So let's start coding. Firstly, we'll have to import all the libraries which we need. So we need OS, then we need NumPy for our math. Then we need to load our environment variables. It is good to keep API keys in your environment variables because it's a secure way. And if you don't do that, so even if you push your code on GitHub, so it is possible that someone would steal your API key and your credits are gone. We need an LLM also. So for this project, I'm using Gemini. It has a pretty generous free trial. We'll load our environment variables. Then we need to configure the LLM or Gemini. So the API key is stored in environment variables and we are just calling it. Then we need to configure our encoder also, which is the sentence transformer model. And the model I'm using is MiniLM because it is pretty light on our systems and it is the best thing for toy RAG projects. Now after initialization, we need to go to our first step, which is the ingestion of data. An LM can't read a 500-page book in one go. We'll have to slice it into chunks. But before chunking, we need to prepare some synthetic data. Let's think of some facts. T20 World Cup is going on, right? So we'll reuse the 2024 one. So it was hosted by West Indies and US, I guess. Then, oh yes, apart from India winning, Pakistan was bashed by US also. Let's keep this. Apart from India lifting the title, US washed Pakistan. Good thing. Then, yes, obviously India won the World Cup in the captaincy of Rohit. We beat South Africa. Who will miss Rohit and Kohli? Do comment. Let's move to some Python also. Python is an high-level interpreted language. And we learned about graph RAG and agentic RAG recently. Let's put them also. Used for creating React loop and capturing complex relations. So now we'll manually divide these chunks. So here we are just dividing it by line. So line 1 becomes chunk 1 and so on. However, this is not the optimal case. We'll talk it like what's the most optimal case for chunking in tomorrow's video. So I'm just splitting the data by lines. So the first line would go into chunk 1, the second would go into chunk 2, so on. Now these chunks are of no use to our LLM. We need to convert them into vector embeddings. So for that we need to call our encoder. So we are going to turn every sentence into a list of 384 numbers. These spaces are fixed into a multi-dimensional space. So you must be wondering why specifically 384. So it is predefined length of the MiniLM model which we are using, nothing else. Now we'll go to the retrieval step. So firstly we'll have to turn every query into vector 2. So whatever query we are going to give to the LLM, we'll convert it into vector embeddings first. Again, we'll call our encoder to do the job. And once we have the vector embedding of our query, we need to basically do cosine similarity once again. So we are basically measuring the angle between question and every chunk in our database and finding the smallest one. So you need to know some basic Python functions to understand this, but basically we are just implementing this formula, a dot b by mod a mod b. Firstly we need this dot product, which is np dot, what all we have, chunk embeddings and vector query vector. Next we'll normalize them. We need normalization because let's say if a dot b is pretty high, so we won't get good results or good angles. That's why we need to normalize them or basically find the magnitude for A dot B. Then we'll have to calculate similarities, which is nothing but the dot product divided by our norms. And out of all these similarities, we need to find the best ones, so we'll use argmax for this. So this function returns all the best chunks which we retrieved. Now we'll come to our final step, which is augmentation and generation. So we need to inject our query, our context to the system prompt, and then finally we'll call our LLM. So firstly we'll have to call our model and then give a system prompt. So I'm using Gemini 2.5 Flash over here. So this is the system prompt. Firstly we'll have to give the LLM a role. So his role is to answer the questions by using the context which we are giving, or which we have just retrieved. This is the standard format how you will give prompt to your LLM. You'll tell him his role, you'll give the context and ask the question. Let's print them out. We'll print the context also, so that we need not go up again and check whatever chunks we are getting out. Like the chunk should be correct, right? Let's give this as query. Who won the 2024 World Cup? I made a spelling mistake, I guess, while coding. Ignore. So we'll print this retrieved context, like the chunks which LLM used to reproduce the answer. And we'll print this answer also. So code is ready to run. Python manual reg.py. So we're starting our model, and ideally it should print India and also give us the retrieved context, which is our chunk 3. So we'll ignore these warnings. Context does not provide. Oops, what did just happen? So we encountered a pretty critical issue, and we spread the data so aggressively that the year 2024 ended up in one chunk, while the winner India ended up in another. So they had no relation in between, and that's why we need graph rag. So the retriever saw 2024 and World Cup in the first sentence and thought this is the best match. So because we told our Gemini to answer using only specific chunks, and that chunk only mentioned the host, not the winner, so Gemini said that I don't know this context. But in basic RAG 2, if you need to fix this, the best way is to use sliding window. So we'll use a sliding window over chunks, like as you have learned in your data structures. So the context is missed. But if we use sliding window, so the ending of chunk A will also be in chunk B. So no context is missed by us. Let's use sliding window. So instead of cutting at each line, we are looking at the paragraph as a whole and then splitting it. So I named it as raw chunks. And then these chunks will also be traversed individually. Obviously we're using sliding window concept over here. So what will happen is, even if a sentence goes cut, so the context exists in both chunks, ensuring that the retriever always finds the full story and not just one chunk. Now let's see by running it. See, we got the complete context and also the answer. Now what if we put something random, like what color is the sky? Now it should give the no context result. But still it will print retrieved context. And why is it so? Because we are printing the best index. And it means that this context made the smallest angle with this query, 2024 World Cup 1. But it was still negative. So a Gemini gave response as no context. So we implemented a complete RAG pipeline manually. Tomorrow we'll be looking into its faster or automatic version which is using LangChain. Stay tuned.